I fabricated first chip out of any institution in India. If you want to do something different, see, you have to really think about it. So we have taped out our chip in 2002, the first chip. When you do any compression and in imaging or image processing, so it covers both image or videos, right? So there are different techniques.
Why did you change your path? Like the career was changed, and also you did not sit for placement.
Yeah, I did work in US
Okay.
through Atheros Communication. I just go down with my colleagues and then take a walk. Yeah, I think creating Instagram reels. Some folks should also work on to achieve the end goal, to final integration.
Okay. So in system engineering, what was like your area of expertise? What did you work on?
In staff engineer, I was given a complete responsibility of, they were doing the first networking chip at that point of time when merger happened.
Okay.
If somebody is aspiring for a VLSI job, I think they should have. I'm not looking for very, very strong fundamentals, but I'm looking for fundamentals.
Hi everyone, welcome back to VLSI for All. I'm Apurva Dikshit, your host for today's podcast. We're back with yet another expert talk on semiconductor industry. We're honored to welcome our guest, Mr. Kavish, who is Senior Director of Solutions Engineering at Synopsys Incorporation. So Kavish, before starting our podcast, we'll do a brief introduction of what you're doing. Can you introduce yourself to our audience? What exactly you're working on in the area of expertise?
So I'm actually, first of all, grateful for this opportunity to interview with you. And I appreciate this effort. I think a lot of process has gone to conduct this interview. So to begin with, I think it's a brief introduction of mine. So I have close to 23 years of experience and all in VLSI industry. So I started my journey with Atheros Communication. That was the first they are in pioneer in Wi-Fi. So they got acquired by Qualcomm. So they don't exist anymore.
Yeah.
And so Atheros was a very early stage startup. So I got opportunity to work in all the technologies there in Atheros Communication. I worked in India, I worked in US locations, and eventually Atheros got acquired by Qualcomm, and it has become Qualcomm Atheros. So I worked couple of years at Qualcomm Atheros, mainly working on emulations and validation, post-silicon bring-up, then moved to Synopsys. Almost 11 years back, I moved to Synopsys. I wanted to do something different, so I wanted to play a role of technical marketing, application engineering. So I decided to move from Qualcomm to Synopsys. And Synopsys, I started taking up emulation application engineering role initially. And I was serving some key accounts like Samsung, Qualcomm again. I did it for a couple of years, and past 5 to 6 years, I'm playing a R&D role. I'm a senior director now, and I have a big team, and we design SoCs right now. And
Okay.
SoCs, and we design the complete system. Some of the SoCs we tape out, make test chip out of it. Some of the SoCs, we just take it to the emulation and do entire software bring up, doing performance the way Synopsys customers are doing. So that is my brief introduction. And in industry, apart from that, I am PhD in VLSI design and image and video processing. So that is my short introduction.
Yeah. So you did your MSR degree and also PhD from IIT
Yeah,
Madras,
yes.
right? So what motivated you to go so much deep into research and then finally coming into the corporate? What exactly motivated you to do the gate preparation? Let's start from there.
Okay, so as far as gate preparation was concerned, so when I was doing undergraduate, and so at that time, I was pursuing BTech in electrical engineering.
Okay.
And for placement, the pattern was like, even for our seniors or even for us, the kind of companies we were getting only like it's a manufacturing companies like plants
Again,
and then
understand.
steel industry. Only for computer science people, they were getting software companies. So we had no notion of VLSI at that point of time. What is VLSI? We were just studying digital electronics, analog electronics, but we had no idea about like somebody can make chip out of it. And so in order to get into a better kind of job, software job, so like I have decided, or like group of us students, they have decided, okay, they should go and prepare for GATE and get into some IIT.
And getting a software job.
Getting a software job, right? So that was the main motive. That's why we started the GATE preparation to do that. So I got a job, not on campus. I got a job off campus, but that was again manufacturing plant. So I did not join that. We started GATE preparation, and answer to your question, like why doing in VLSI, right? And VLSI design. And final year of our BTech, there was one of our alumni who came from US. He was working in US, and our institute, they have conducted some presentation for all of us, like so that he can inspire the students. So apparently that person was working. He was a scientist, and he was working in some foundry.
Okay.
So like foundries were very rare way back,
that
like
point of time, yes.
almost like 24 years back. So it was very rare. So he was a scientist, and we sat through his presentation, and then he kind of explained like how do they make chip,
Okay.
how the different chemical process. He was a chemical engineer. He was explaining the chemical process, and he also bit of explained like how they transform like SOCs, the digital small, not SOCs at that point of time, but chips, like digital circuits into into a like cast and then fabrication, and how they finally make chips. Right? So it was very, very fascinating for me. So at that time, I have decided, okay, so like let's
Doing
go
PhD.
rather than doing control systems, instrumentation, power electronics, or power systems. Let's only try for VLSI. So no matter what, like I should be getting enrolled to only VLSI courses. I got a GATE score, and I was in MTech. I was getting, other than VLSI, I was getting all other streams.
Oh, yeah. The most difficult, toughest one to crack.
The percentile was, I think, close to 99, but I was getting, I could not get anywhere MTech in VLSI. So I was getting into all other streams, control systems, instrumentation, power electronics, which I didn't want. So I started trying for MS. I had no idea about what is MS at that point of time. So I started trying for MS. Okay, at least I will get MS, and I'll get master's degree from IIT. So I applied everywhere. So I got into IIT Madras.
At that point of time, I suppose there were not many IITs offering MS degree as well, but now most of the IITs are
So
offering that.
only 4 IITs were offering MS degrees.
Okay.
And not all of them were offering MS actually in VLSI. So MTech degree was there everywhere, almost all the IITs, but now MS not everywhere. The IIT Kanpur was MS Microelectronics, not in VLSI design, right? So
Right now it is because I am MSR.
earlier it was only MS in microelectronics. So you end up working on devices, device modeling and all. And IIT Madras, IIT Delhi, IIT Kharagpur, IIT Bombay, they were offering.
Okay. So what all differences did you see between MSR and MTech degree at that point of time?
See, at that point of time, I think it was MTech was like mostly courses. The practicals, or I'll say lab, were very, very less. Okay, so you just go through the courses, and you do some assignments and few labs. It was not very practical approach, I would say that. And then you just get out in 1.5 years,
Right.
and take up some job from campus placement. Right, that was the thing.
Right.
But in MS, it's a very wider platform where MS, you have to really do research. It's a mini PhD, right? So it's more of exploration, innovation, and then you have to implement complete project,
Right.
presenting papers, giving seminars, defending your thesis. So it covers all the aspects.
Yeah. So basically, if you're getting into MSR degree, your expectation from your supervisor also is more because, as you said rightly, it's a mini PhD.
Yes.
Yeah. So these were the only differences. And as per placement, did you see any difference?
Placement, there was no difference. And placement, actually, at my time, companies are preferring MS people over MTech.
Oh, okay.
Okay. So that was a trend. So I don't know now, but
These days I don't think so. It is now anymore. But yeah, I also feel that there's no such difference in placements. But yes, the requirement and expectation from your supervisor is much more from an MSR student.
that's true.
Yeah, right. And also, I've seen, I don't know about your time, maybe you can correct me, but 2 years is strict for MTech. People to pass out, students to pass out, but MSR can be extended. So, what was your duration?
So my duration was 2.5 years.
Okay.
So apparently our senior batch of MTech, they just got out in 1.5 years. So that was the last batch.
1.5 years?
Yeah, 1.5. It used to be 1.5 year earlier MTech.
Oh, okay.
And then from our batch onwards, it was 2 years. And so 2 years, my classmates, they passed out MPEC.
Okay.
And then for me, it took 6 more months. There was a reason behind. So why it has taken 6 more months. So I think once you ask more questions,
You can tell me, right?
Yeah.
You can tell me.
Yeah.
What was the reason?
So reason was I was trying to do something different in my project. So
Okay, your thesis work.
So I fabricated first chip out of any institution in India.
Oh,
Okay.
okay.
Yeah, so I'll tell you the story, but that was the reason it took 6 more months to do that. Otherwise, I would have also completed 2 months, 2 years, 2 months type. Okay, but it took a while because I wanted to see my chip. So that was the reason.
So this whole process was going on inside IIT campus? Okay. And at that point of time, I suppose this IIT Madras was the only one.
We were the
capable
first
of-
one. We were the pioneer to do any tape out at that point of time.
And setup was also present in other IITs?
It was not there anywhere. We brought it up at that
Right.
point of time.
Oh, okay. That's very interesting. Yeah. So what was the chip? What did it do?
So as a part of, so there's a story behind it. So when I was in first year of my MS, and it was, if conventionally you look at, the people will go and then they will look at what their seniors have done, or they go through, otherwise they go through papers, and they'll figure out something which is of interest of your guide, right? His domain. You cannot go.
Mostly it is that one.
Yeah, you can't until unless it's, I think it's a very path-breaking stuff. You can't go and do something which your guide is not interested, not his field, right? So
Yeah, that's how we used to choose our professors as well.
and guide will also kind of suggest you or sit with you when you collect all the papers, go sit with him, discuss. So I walked up to my guide saying that, what should I do? He said, so that time we have gotten, the government has given the some funding. So there used to be a Department of Electronics, part of Information Ministry, and they wanted to promote some VLSI in India. So they have given some budget to all the IITs and subsequently to all NITs. So the part of that budget is you will get tools from Synopsys and Cadence, and some machines and some other vendors. So like for Spice and all those, like Tanner Spice and all that. So the tools came in, and my guide was in charge of that whole thing, whole initiative. So he asked me, Kavish, if you want to do something different, I think first you have to open up the tool set, install it. See, everyone does a very conventional way in my group. They come up with some problem, they implement in software, Verilog or VHDL, and then they do it on FPGA, and then they show some output, and that's all about it. They publish some papers. If you want to do something different, see, you have to really think about it, how we can make use of these tool sets and do something different. So that kind of got stuck into my mind, or rather I have taken it as a challenge. Okay, I had to do something different, my guide is saying. So I don't want to do the kind of projects people are doing, and my guide is asking for it. That was a motivation to pursue that. So I installed everything, and there was another professor at IIT Madras. My guide is no more, Dr. Srinivasan. He's no more in this world. But there's another professor, Dr. Vinita Srinivasan. She's also part of VLSI department in IIT Madras. She's a very, very senior professor right now. So she was also very, very supportive. Okay, let's do something different. We opened the bundle, installed it, started doing things. There were a lot of hurdles. Okay, and then whatever I have defined for my MS, I put together the complete design. I did everything. Okay, though all the vendors helped, like Synopsys helped, Cadence helped to do that.
Okay.
We also got Foundry, but there was a big thing like who will fund for the tape out? There was no Foundry. There was SCL was there in Chandigarh, but they were not doing so well at that point of time. Who will fund and how we can tape it out?
Okay.
Right? That was a big question. As I mentioned, like my supervisor, my guide, and then Dr. Vinita Vasudevan, they were very supportive. So they arranged some funds and asked me if I can convince the vendor or the fabricator who can do it at very less cost.
Okay.
I was like, very young, and then
How would you find? Yeah.
that time. So I say, how can I do that, right? So how I can go and talk to foundry people and say that, oh, reduce the cost for students. So we contacted in the whole thing. We came across something called Euro Practice. They're still there, right? They do some MPW tape outs for students or small organizations. So I came across this Euro Practice, and then we started interacting with them. And then eventually it got materialized. We could arrange whatever funding we had, we could arrange the tape out in that. So
Okay.
my design and one analog design has gone together in half of die. So we have taped out our chip in 2002, the first chip. Right?
Okay. Yeah.
It was like at that time node was 350 nanometer. It was a pretty
350.
350 nanometer.
Okay.
Yeah.
But still a big deal.
Yeah, we were very naive. So we taped it out. It came back. They rejected our GDS2, saying that, oh, it's not appropriate.
Okay.
Because we were doing first time and we had no idea. They were supportive. They say you forgot to insert filler cells, right? It was
Okay. First attempt here. So
yeah. Then we did. We took couple of days. We did the due diligence and we sent it back. And it took couple of months because it was MPW, and we could manage to get the silicon in our hand.
what's MPW?
MPW is a multiple process wafer.
Okay.
Yeah. So we can, my design can go on same wafer, your design can also be accommodated. See, generally in industry, there's a wafer, all dies, they belong to one design, right?
Right.
It can belong to other design.
Other design. Multifunctionality here basically.
Yeah. So my die, your die, somebody else die also come on the same wafer.
Okay,
Yeah.
okay. It's like that. Okay. So what did the chip do, which you designed? What was the design?
So chip it's a wavelet, discrete wavelet transform processor.
Okay. Can you explain that?
When you do any compression and in imaging or image processing, so it covers both image or videos, right? So there are different techniques we follow. So this is one of the technique where we remove the redundant information from the image, right?
Okay.
So this is called transform. So people use discrete cosine transform earlier. Now people use discrete wavelet transform.
Okay.
So this is one function of incomplete compression chain.
Okay.
Right? Compression chain or decompression chain. So part of this is the heaviest part of that.
Okay. Your specialization was signal processing.
My specialization was VLSI design and image processing.
Image processing.
So even image processing, eventually you can correlate to signal process. Yes, image processing does not get completed without signal
processing. So as you had started telling about your motivation, you said that you wanted to grab a software job. So you landed in IIT Madras. You were doing your MSR degree. Why didn't you sit for placement to get a software job? Why did you change your path? Like the career was changed. And also, you did not sit for placement. Why did you opt for PhD then?
No, I did sit for placement.
Okay, okay.
So I see now doing MS in VLSI, nobody will look for software job anymore, right?
Right.
That would be the bad choice.
Right.
Okay, if I appear for software jobs after taping out a chip or from my
completely
yeah, so that
changed.
that was complete. That perspective was completely changed.
But did you see a disparity between the packages that were offered at that point of time?
Yeah, there was a huge difference. So
What's your
like
tip?
we were VLSI was elite at that point of time. So it's like a VLSI. Always, I think we used to get 2x, 3x packages than compared to other software companies. They're
Oh.
coming to so yeah, it was elite. Yeah, all elite. Like you are privileged if you are that point of time.
At that point of
And a lot of companies they used to give direct placement in US at that point. Okay, there's no placement in India. They are not based out of India at that point of time. So you just directly get placed in US. So a lot of companies are coming even during that type.
So what was your placement like?
I got into 2 companies. They did not allow me after that. So I got it to Sanyo. There was a company used to call Sanyo at that time. So when their VLSI division, and I got into Atheros Communications. 2 companies I got placed.
Okay, so Atheros was your first company.
Atheros was my first company.
Right.
Yeah.
You also went to US?
Yeah, I did work in US.
Okay.
Through Atheros Communications.
Atheros itself. Okay. So you worked here first, then went to US?
Yes.
Okay, all right.
I came back just to do PhD, right? So
Oh, right. Yeah. How did you, what motivated you to do PhD? So you joined the job. After that, you did your PhD.
Yeah, so I actually worked a couple of years. So I wanted to do continuous, like I want to finish my MS and I pursue my PhD.
Mm-hmm.
But I want to pursue not from IIT. I wanted to do from MIT.
Okay.
So there's another, I think, a small story behind that. So why I wanted to do MIT, and I got admission there in MIT, but I could not pursue in MIT. But that thing was still there. Like I had to do PhD, right? So and then my supervisor or my guide, they convinced me, okay, it's like if you do there and here and all, like if you want to do, just do it. If you are interested to do the research, just come and do it. So I then opted for again IIT Madras.
So why did you not go to US, MIT?
So MIT, when I was during my MS days, so a lot of people used to come from different places, like but all people who are there, I think they are pioneer in their field, or they from industry or academia. They used to visit IIT Madras, whether they are alumni or they were invited and or as a guest, right? Or they wanted to do some collaboration with IIT Madras, and they used to give some guest lectures for all of us. So there was a professor I remember called Dr. Ananta P. Chandrakasam. He was so he's the guy who started the low power. There was no notion of low power earlier,
Hmm.
before 2002. People never used to talk about low power and all those things. He was the first one who started low power. And apparently he came and we had no idea who is that guy. But he gave one lecture and I was very impressed. Like, oh, something we can do in low power, right? And like people are not talking about like batteries and all those things those days. But still, I was very impressed how we can do reduce the power in our ICs. So I decided, okay, let's do PhD in low power under Dr. Ananta P. Chandrakasam.
Okay, this was during your MSR.
Yes, MS, yes.
Okay. Okay.
I determined to do that, and I became so interested in
Hmm.
my research work. I started implementing some low power features.
Oh.
I used to study, and then so I did I have come up with couple of algorithms in my design itself to reduce the power. Okay, so that was the impact, I would say, of
Mhm.
that talk.
Of
Okay.
that lecture, yeah.
I went through the process of writing TOEFL GRE, but timing was very bad. It's 2002. There was a deep recession in entire world. So companies were getting closed and no fundings anywhere. .com and then 9/11. Two things happened, right? .com bubble busted and 9/11 happened. So this, so I approached and the professor said, "Oh, you can come here, but I won't be able to give you funding."
Okay.
And it was so expensive. So it was like a trimester base and it was almost like 25 lakhs per trimester. Okay, so he says, we will see, come for 3-4 trimesters and we'll arrange some funding for you. But you know that 25 lakhs was a very, very big amount
At that point.
at that point of time. That's to like you spend in 4 months, 5 months time frame, right? So I could not, and banks were not giving education loan like now. Okay, if you approach, they will give you education loan, plus some property and all those things, and do that. I didn't want to do that. I didn't want to bother my parents to arrange all those things. So I decided not to pursue at that point of time. But the desire was there always to do PhD. So
Yeah.
that I think later that prompted me to do from India itself, and then interest of my subject.
So as you said that you had designed the chip, that involves both analog and digital. But what was the area where you were more inclined to?
No, I have not worked on analog.
Analog, yeah.
Analog was another guy. So there were two designs has gone on the chip, and chip name was Kaveri. Okay, so Kaveri was like a sacred river, and then my guide has a huge, I think, thing respect for that. Okay, so our sentiments for the Kaveri river.
Okay.
So we named it Kaveri. So so he has done something related to some analog corrections. Okay, so that was a totally different design. Half die was mine. So there I have put complete digital. So I have never worked on analog design in any point of my life.
So we can dive into the rapid fire round just to make it little interesting. Okay. So I'm going to ask you questions and you have to answer very rapidly. Whatever the first thing that comes in your mind, you have to say.
I'll try.
Yeah. So the first question, what's a guilty pleasure when you need a break from work? When you're in office, what do you do for a break?
For a break, when I'm in office, what do I do?
Yes.
I just go down with my colleagues and then take a walk.
Take a walk.
Yeah.
Okay. So if you could have dinner with any tech visionary, dead or alive, who would it be?
I would actually want to have dinner with Steve Jobs.
Steve Jobs. Okay. What's one hobby or interest you have that might surprise your colleagues, which most people might not know of?
Yeah, I think creating Instagram reels.
Oh, that's interesting. So, if your work style were a movie genre, which one would it be? The rowdy one? How would it be?
I love actually sci-fi.
Okay.
Yeah.
Which is your favorite movie?
I actually I like the movie like Deep Horizon.
Okay.
Yeah.
I have not seen that. What it is based on?
It's all based on theory of relativity.
Okay,
Yeah.
okay. Okay.
Yeah.
I'll have that on my watch list. Which tech gadget can you not live without even on a lazy day?
Mobile phone.
That was simple one.
Yeah.
What's the best piece of advice you have received that still inspire you today?
Best piece of advice I received so far is if you are into some problem, have a dialogue
Have a dialogue.
with a person.
Okay, talk it out.
Yeah.
Okay.
Talk it out.
Do you have a secret talent or skill outside of engineering?
Outside engineering, I am actually very good at video editing.
Okay,
Yeah.
okay, nice. If you could swap roles with anyone in your company, who and what role would it be?
In my existing company.
Yeah. You can say no.
Uh,
I don't want to swap. But is there something that you would like to do? Or any other profession, let's say?
any other profession, but yeah, if you look at my hobbies, maybe I can swap with some movie directors, right?
Movie director. Okay, nice.
Steven Spielberg, yeah.
Oh,
Uh,
great. What's your favorite way to unwind after a long day when you get home?
Talking to my wife.
Nice. Which song best captures your mood on a busy day?
I actually love Tamil songs. So yeah, there's a song called Alai Paide, Snehidani. So I generally listen to that.
But you're from UP.
Yes.
You understand Tamil,
Not much, yeah, bit of it, yeah.
but like songs.
Yeah.
Okay. Very interesting. So yeah, getting back to our conversation on your current this semiconductor industry. So next question is, as you have like studied in IIT Madras, done PM, MSR, PhD, what in your opinion is basically the impact of the curriculum that you had and how it is supposed to change, or is it okay for the corporate, for getting ready for the corporate?
See, curriculum is pretty good, but I would not say it is okay for corporate, right?
Hmm.
So there are two approaches there. So this approach is, I think, is a theoretical approach where you get through a lot of courses, right?
Right.
And then, so that is one aspect. But another approach is a pragmatic approach that I feel is very less.
Hands-on experiences on
Hands-on experience is less. Yeah. So it's like it's the assignment, and assignment you get, the assignments will not carry much marks for the students, or we are not able to motivate the student to have hands-on. So, and then hands-on also when it comes, I think people just want to somehow finish the project. So they are not really interested because everything they are doing to just gain some marks, right? So that is there's a whole intention behind that. So the real intent is not coming out, right? For even for assignments or whatever hands-on experience you gain during your studies.
Right. And also we see that for some of the companies who come in the placement, they have a cutoff limit on the number that CPI
Yeah.
might have. And so people have to study and
Yeah, there's always race for them to get
Yeah.
more marks,
more
not
marks. Yeah.
CGPA, right? So
But they could also include such projects and they could, judge or basically mark on that. So they can have hands-on experiences of
yeah,
these tools as well.
I
What
believe so.
tools would you suggest should be included?
See, whoever nowadays asks actually this question, I have only one answer. So one answer is when you design a curriculum or is a part of curriculum. Okay, at least when you do a project should be based on the understanding of a system. Okay? System, I mean, is you should know what is the end goal of that system. It should not be just sake of the project. I'm just implementing this algorithm, that's it. If you ask, like we do conduct interviews for many folks, right? And even freshers, we ask, why have you done this project? What is the rationale behind designing such algorithm? But they are not aware of the end goal, okay? How, where it will be used. So always we should define an entire system for a group of students. Okay, this is the end goal. You have to achieve this. You can divide the problems into many problems, and those problems can be given as a project to the students. Some people will work on design sides, some people work on verification sides, some students would work on prototyping, FPGA prototyping, on emulation, validation. Some folks should also work on to achieve the end goal, to final integration and running the use case application. So you keep hearing about use case, workloads, and nowadays, right? So that I'm watching for actually since beginning. So that I think we should know where. So until unless a student would see that something is happening like this, they're not going to learn. Like,
Right.
okay, so they will learn when they come to industry, they join industry.
Right. That is there.
Yeah.
Okay. So you started with Atheros communication, right? And your profile was design verification engineer.
Yes.
So what was you were working on that at that point of time?
So that see, my initial assignment was to verify CPU.
Okay.
So that I started with that. So the first thing I did is I have written the assembly code to validate some of the CPU features. Then switch to the Vera. There was a before UVM has come in. Is to call language called Vera.
Oh yes, yes, right.
So I worked on Vera.
Okay.
And then system Verilog. Even before even they could come up with the UVM stuff, there was system Verilog.
Yeah.
So this I worked on this, and I think validated some of the IPs or interfaces at that point of time. So that was my role.
Okay. And then you transitioned into DFT and system engineering.
Yeah.
So what influenced that decision? What all responsibilities were there then?
See, DFT was since it was a startup, so we were asked like you based on the need you had to do something. So there was a need for DFT at that point of time. So I started doing DFT, and as a part of DFT, when chip silicon used to come, we used to go to test house in US Bay Area, and then run those functional vectors or scan vectors. So there used to be a big tester would be size of like half of the size of this room, and then there should be big load boards where we load our wafers or silicon. So I used to just look at those boards very carefully. We used to call it load boards, and sometimes I used to laugh in my mind saying that, oh, why do you call it load boards, right? Where we are loading, like with all those things I got interested into a board. So that was one, I think, key factor or defining factor. I got attracted toward boards. And there was a colleague of mine, he used to do emulation and silicon bring up. And he used to find a lot of bugs, and he used to get, I think, uh, admired or praised for that everywhere, across entire company. Oh. So his name was Ravi Subramaniam, and then he eventually has become my boss. Okay. So I got inspired because I used to work very close with next desk, whatever he was working, and then I used to see him working whole day, and I used to get a lot of inspiration from him. Then I decided, okay, I'll work with only Ravi, and I'll work on system side. So that's how I transitioned myself. I requested my company to move to him, and they were very supportive, so they did that. And since then, I learned a lot of stuff and from Ravi, and I have become system engineer.
Okay. So in system engineering, what was like your area of expertise? What did you work on?
As a part of systems engineering, we had to play many roles in as a part of systems engineering. So it does not come with only just one technology.
Okay.
So as a part of it is FPGA prototyping, at least as far as Atheros was concerned. FPGA prototyping, and then pre-silicon validation.
Okay.
And then your test board designing, customer board design.
All these responsibilities.
All these is silicon bring up. And then post-silicon bring up, validation, characterization. So it's many streams in that. Okay, so I handled almost all of them.
Okay, nice. You also served as visiting faculty at IIT Madras and IIT DM Kanchipuram and IIT Madras.
Yeah.
Oh, how was the experience? Why did you decide to do that?
It's always, I think, teaching was somewhere in corner of my mind. Okay, so I should be teaching students in my own way. like with more practical. So they have floated embedded systems course, and I was just finishing my PhD, or just finished and submitted my thesis and waiting for reviews to come back. So
Okay.
I worked such a long time at IIT Madras. A lot of faculties they know me, or some of the faculty members they finished PhD before me because I joined little late. They were faculty there. So,
Okay.
and so they approached me saying that Kavish, why can't you take this course? You are already like as worked as a systems engineer at Atheros. So that somehow there was a motivation, right? It was teaching was there somewhere in corner of my mind, and then I say let's give a try and teach students in a very very practical way. So I've taken up the one semester. Right?
Embedded systems.
Yeah, embedded systems.
Okay.
Class of MTech, and so the good part was I think initially there was people were not students were not understanding, like, because my approach was too practical. They were used to do all theoretical stuff, right? Book stuff, and they used to come to me saying that, sir, from the syllabus is this, but you are not teaching this, right?
No.
So, but I told them, if you would go to industry, I think you also need all those things. I'm not saying that your syllabus is bad, but you also need these other aspects. I think they understood. I think, and see, by myself, I could place a lot of students, right? I actually taken many students even in Atheros communications after that. Yeah.
Okay.
It was a very nice experience.
In between.
In between, yeah.
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 So, how did it happen? Basically, what was the chemistry or the kind of communication with your company? How did this happen? Like, you went to do your PhD, then came back, so they were like in on that whole journey of yours.
Yeah, so I actually take just a year off, okay, and then I came back, and then most of my research when I was doing, I was working also and doing it.
Okay.
Yeah.
Yeah. So it was not like a break.
It was not a complete break.
Okay. Okay. So after Atheros, you joined Qualcomm as staff
Yeah.
engineer. What was your responsibilities there?
In staff engineer, I was given a complete responsibility of, they were doing the first networking chip at that point of time when merger happened.
Okay.
So Qualcomm has never done earlier. Atheros had never done. So they wanted to do, because two companies have come together. So they wanted to first a network processor, and I was given a responsibility to emulate it. So I had a team of engineers, and I was leading that effort. So we could successfully emulate the entire chip. So
Okay.
that was my role in.
So what prompted you from shifting from Atheros to Qualcomm?
No, there nothing prompted. It got acquired by Qualcomm.
Achha, right. You had mentioned that.
Yeah. So you are part of it. It's like,
Yes, sir. Yeah. So then at Synopsys, how was the transition then from Qualcomm?
see, there was as such, there was no problem working at Qualcomm, and because I was liking it, and like it was also a good experience, but somehow I wanted to do something different at that point of time. And I wanted to shift to some kind of technical marketing support, and I wanted to gain some different kind of experience. Yeah, so not all the time development. People caution me, like, not to join EDA company because you are a part of product company. Yeah, it might spoil your career or whatever. But I was determined, right? I wanted to try. Yeah, so if you wish something, there's no harm trying that. So that's why I transitioned from Qualcomm to Synopsys, because Synopsys, they were offering me application engineering role. So the role was such that it was like you had to interact with customers a lot, deploy our tools or hardware or whatever, and then even support them. So that was the role. So that was a primary reason to move from Qualcomm to Synopsys.
So this is what you also wanted to experiment on.
I want to experiment it,
Yeah.
because somewhere I thought, because I used to see people in sales, marketing, and other domains other than the technical domains, how they function. I also wanted to uh, undergo such kind of experience. Okay? So being a technical guy, it's not possible tomorrow we wake up and say that, oh, I'm a sales guy today, right? Yeah, so we should have some kind of gradual transition where you just shift like bit gears. Not I'm saying that you cannot shift a big gear, but you can shift a bit of gear, and then you can try to adopt something which you can function where you can function well, right? So that was a choice to become application engineer.
Any challenges did you face during this transition?
I actually faced a lot of challenges because it was very, very new to me. So I had never experienced like when you and support some customer uh, against whatever you have product or hardware you have sold, like the kind of pain or pain points they experience. Okay, and then and it comes to you in some way, right? You are because they have taken from you. So
Yeah.
initially it was very difficult. The way customer was giving us back, saying that, oh, this is not working, that is not working, what you guys are doing, right? So initially I did not like that kind of attitude, but eventually I understood that is a part of the job. Okay,
Yeah.
so
So shifting from a technical background to a managerial position, did you feel like there wasn't any need of a managerial degree or anything, or it was
actually, for me, it was a very gradual shift
Hmm.
because from Atheros days, like I had couple of folks like under me, and then like having a big team now, big size team. So it was a very gradual shift, and then in this shift, in this transition, I have never lost my technical identity. So still, if you walk up to my office, I'm very, very hands-on. You will see me working, coding something all the time, and then managing people at the same time. Okay, but only one thing I learned: the moment you become manager, it's not any individual stuff. It's not me, my work. It's you carry the responsibility of whole team. Okay, so you have to refrain being by yourself, right, at that point of time. So that I think you have to be consciously, you have to change your thinking or your mind, and it should also reflect in your attitude. So
Right.
that's the only thing I think I have done it, but there was no major difficulty I faced. Yeah.
Right. So you have 23 years of experience in semiconductor
Yeah.
industry, right? And how long you have been in the managerial responsibility position?
18 years.
18
Yeah.
years. So many freshers might have come to your
Yeah.
team. How do you like analyze them, their performance, and what do you feel like they should not worry about or they should more focus about? What is the overall overview of the freshers who come these days now?
These days, freshers are coming. I think I find actually in 80% of the people, I think fundamentals are missing.
Hmm.
If somebody is aspiring for VLSI job, I think they should have. I'm not looking for very, very strong fundamentals, but I'm looking for fundamentals.
Okay.
Right. So that is, I think they have to work on that skill. Fundamental skills are there, and then see, it's not you just want to work on VLSI domain, hey, and you just come and attend interview, right? You should also work towards that. So that is one aspect, and they should be very, I think, prompt fixing that.
Okay. So are these the skills that you're talking about, or might have already done some projects that you're basically talking about? What are these?
Yeah, so it's a
Fundamentals.
mix of things, right? So people they say they have done the projects in VLSI. Okay, but if you have done project in VLSI and then fundamentals related to your project,
You're not knowing of.
yeah, so should must carry with you, right? And you
Right.
should not be missing those.
Hmm.
Okay, so that I find very, very frequently. Generally, see, whatever you learn, like you are done in project or anything, it might not be 100, like you cannot be as it is used in industry, right? So only thing we have to we see like how fast we can ramp up the person so that he can work on our projects.
Right.
Okay? It's very rarest of rare where you get some guy from academic directly or fresher, like he has worked on exactly same thing you are working. Otherwise, yeah, you end up remolding that guy to some other
Team.
thing, yeah, and other skills.
Yeah.
The another aspect I think for the student is I think this they should be apart from like fundamentals of VLSI, they should also have good know-how of scripting, some programming language, okay, Linux, Okay,
Right.
they come and then most of the people they are not very well versed with Linux or scripting or shell scripting. But so those I think these are not mainstream things to learn, but I think those are very essential.
Essential, yeah. There are plus points of
Yeah,
the
they're
students
plus
already.
points, right? I generally the guys joining on very first day, we can just instruct do this way. Right? Otherwise, we have to just spoon feed everything.
Yeah, right.
So these are the very essential things. So work on your scripting, Python, Perl, Tcl, whatever it is, right? And Linux, OS, all commands, everything. All those fundamentals you should have. Very good fundamentals you should have. So if you have, I think no one can stop you to, I think, perform much better than compared to your peers. Yeah? So
Right.
these are secondary, but primary is still fundamentals, logic.
Fundamentals.
Okay? Or you have learned some tools, right? And you already have knowledge of tools. See, these you can correlate, right? If you know tools and all those things, and then you know Linux and all those things, and then if you know Makefile, all those fundamentals, right? How fast you can get ramped up? You can understand the environment, and you will be productive in very short amount of time.
Exactly. So as you said, the scripting is one of the plus skills that students can have for grabbing a job. So these are basically automations, right? These are required for automation. How do you see automation in your area? How it has influenced or helped in more efficiency, and also how it has changed the whole work environment.
So yeah, automation was there always, right? It's not a new thing like it has come now. Right?
Okay.
Only people talk about AI
Hmm.
in past couple of years, but automation was there, and automation always helps. Okay? So it helps to increase the productivity and the quality both.
Hmm.
Okay? So something we check through automated way, it may much more foolproof than you go and check something manually,
Right.
launch something manually. Automation also helps in to execute things in non-working hours for human. So that's what increases the efficiency, productivity, and the quality of your design or product. Right. So that's how automation helps. So you should always push for automation, and
Right.
in order to do that, you should be knowing scripting and all those things. Right. Yeah.
Hmm. So, anyways, AI you have seen being used in your area.
Yeah.
How these apart from automation.
See, as far as Synopsys is concerned, I think we are. So Synopsys is as far as a EDA is concerned, EDA industry is concerned. Synopsys is pioneer in AI, and Synopsys has come up with a lot of AI-driven EDA products.
Okay.
If you look at right from design to physical design, we have brought in artificial intelligence everywhere in all aspects of chip design. So that is one thing. So that is for customers, right? For us, it's more work, right? So because we have to innovate. We have to almost innovate every day. We have to come up with some innovation, and we have to implement.
Hmm.
Right? And we also talk about now. Synopsys is talking about agentic AI.
Okay.
So we are creating agents for everything, all the functions at this point of time. So
Okay.
this is from as ED industry, right? How ED industry and including Synopsys, which is marching towards. And you can also see a lot of AI intervention in even in normal course of life, where we are using all Gen AI tools or GPTs and Gen AI tools to even taking help at this point of time to write codes, test
Yeah,
benches and all
scripting, yes, that is
scripting,
also
test benches. They are not fully there. Okay, it's not you cannot leave you can leave everything on them, but you are taking a lot of help. So right now you must be feeling your efficiency is going very high, right? So because whatever you could finish in couple of days, you are finishing in couple of hours. Okay, I've seen cases where it's getting finished in couple of minutes. The similar problem has taken couple of days and it's getting finished in couple of minutes. Okay, so I've seen that kind of improvement in efficiency.
So, any trends that are coming in VLSI industry that you are excited for? Any new changes
Actually, if you are talking about AI or non-AI or in general,
in general?
I'm actually very excited about chiplets.
Chiplets.
Yeah,
Okay.
at this point of time.
What are these?
Chiplets are tiny chips
That-
which you can connect, and you can in a single package,
Okay.
and then you can create a very large system.
Hmm.
people are talking about hundreds of billions of transistors on a single die, but that poses a lot of challenges related to yield. Okay, so it's not if you have hundreds of billions of transistors on single die, your yield might be very, very poor. Okay, you will have a lot of issues. Okay, with related to chip, right? So and then yield will be very low. Yield means like if you make 100 chips, maybe 10 chips might work, right? And there could be a lot of other issues. Okay, where and also related to the life cycle of the chip. These chips, they are very huge, and they run in data centers, right? And then they run all the time. So their lifespan is shorter than your mobile chip or any other chip in the in the industry, right? Okay. Now people have figured out. I think this we have exhausted the Moore's law, right, on a single die. So we want to have a tiny chips we can build, and then we can bring them together on a single package, and then make a larger system of hundreds of billions of transistors. Right? Okay. So that is so I'm very fascinated about chiplets because that's the future. That's I say near term future, right, for our VLSI industry.
So that brings to our last question. What is your take on VLSI for All YouTube channel? What they are doing for students? How do you see that?
See, as far as I keep seeing Raj's post on VLSI for All, and I have looked at some material. It's very impressive, right? So the content the VLSI for All team has put together for students or freshers, I think the content is very, I think, substantial. And my personal view, I think that's a effort to bridge the gap between industry and academia.
Yeah, that is what we were talking about.
Yeah,
To bridge that gap.
bridge the gap. And the part of it is, I think, the tool learning is happening, and then the whatever you were talking about is scripting, all the aspects they are being covered. And along with, I think this is also platform is promoting some open source
Right.
IPs and tools and all. Okay, so not everyone has access to the tools from EDA vendors, and people still want to learn. And like it's and the people who can't afford, but this platform is open to even those students. Okay, on rural side or countryside people who can't afford, like they can just go through the YouTube lessons or use open source tools. Okay, so two things will happen. First, they'll get motivated. They will know what is VLSI. They'll get motivated. They'll get some inspiration.
Yeah.
And they will also, because whatever limited capacity open tools, open source tools or IPs, okay, they can use, they will use. And they will also have hands-on experience.
Hands-on experience. They will be prepared for it.
They'll be prepared, right?
Yeah, job interviews.
Yeah,
And all.
job interviews and all those.
Yeah. So that was an insightful interview. Thank you so much, Kavish, for coming.
Thank you, Purva.
Yeah, coming for this podcast.
Yeah.
We'll see you for another expert talk.